In the long run, all inputs are variable, so the competitive firm adjusts those inputs to equate price with long-run marginal cost, and entry and exit eliminate long-run profits, as price is driven down to the minimum point on the long-run average cost curve. And of course, quantity supplied equals quantity demanded. Consider an example in which all firms have the same total cost curve and sell in a market with demand as given. To create the usual two-part diagram, we find average cost 0.01 Q squared minus Q plus 40. Marginal cost 0.03 Q squared minus 2Q plus 40. And inverse demand, P equals 25,000 divided by 1,000, minus 0.001 Q. Entry or exit will drive price to minimum average cost, which occurs where marginal cost equals average cost, or where the partial derivative of average cost with respect to Q is equal to 0. So 0.02 Q minus 1 equals 0 implies Q equals 1 over 0.02 or 50. Average cost evaluated at 50 is just 0.01 50 squared minus 50 plus 40, which is 15. Since there is a single level of output that minimizes average cost for each firm, we can identify how many typical firms can coexist in equilibrium. That is, how many firms, each producing 50 units of output, would be needed to meet market demand at a price of 15. So we want to find how much N times 50 would be equal to 25,000 minus 1,000 times 15, or N is going to be equal to 10,000 divided by 50, which is 200. Therefore, in a competitive equilibrium, 200 firms, each producing 50 units of output, thereby generating zero profit, would just cover the market demand of 10,000 at a price of $15 per unit. How do sellers respond to a shift in demand? A shift out in demand from D1 to D2 would initially cause the price to rise to $28, causing each of the 50 firms to expand output along their individual supply curves up to 60 units. But at this point, price is greater than average cost, so each firm earns profits equal to the red rectangle. This in turn attracts entry, shifting the short-run supply curve from S1 to S2 and driving price back down to its original level. So, with free entry and exit, one would expect long-run supply to be horizontal. There are exceptions. Suppose the demand for inputs, say labor services, by this industry is large relative to the input market, and suppose the input supply curve is upward sloping. Then expansion by this industry in response to a shift out in demand would lead to an increase in the wage, or other input price, causing average cost and marginal cost to shift up. The diagram shows minimum efficient scale falling, which is plausible but not necessarily true. What is true is that equilibrium price must now rise, and there will be a new number of sellers supported by the new equilibrium. Can you draw the corresponding diagram for a decreasing cost industry? This might occur if production in an important input market is characterized by increasing returns to scale. In all of these cases, adjustments are made in response to an exogenous shift in demand until no seller has an incentive to enter or exit the market and quantity supplied equals quantity demanded. That is, a new equilibrium is established.